Hi, morning everyone. Hope you all fine today. So today we're going to continue our lesson on chapter 2, evaluation of experimental data. As we discussed in previous week that the chapter comprise the details on significant figure, types of error, precision and accuracy, confidence limit, and also Q-test. So as for last week, we already covered significant figures and also types of error. So however, I'm going to discuss a little bit to get you refresh back the significant figures and also types and errors. So as for significant figures, there are certain rules that you have to remember. So the first rule is any digit that is not 0 is significant, which for example 1.234, we have 4 significant figures. And for 12.3, we have 3 significant figures. And second rule is 0 between non-zero digit. For example, we have 606. So the zeros between non-zero digit, we count it as a significant. So for 606, we have 3 significant figures. And third rule, zeros to the left of the first non-zero digit are not significant. For example, we have 0.08 and also 0.012. Only 8 and 12 is counted as significant figures. So we have 1 and also 2 significant figures. And rule number 4, the 0 exiting to the right of the decimal point and 0 at the end of the middle are significant. So we have 2.0, 0.2900, 0.00402. So the zeros after the decimal point is counted, but before the decimal point we not counted. And lastly, the numbers that do not contain the decimal point, which is do not contain decimal point, zeros after the last non-zero digit may or may not be significant. For example, we have 400. So 400 can be 1 or 2 or 3 significant figures. So as we discussed also in last week, the addition and subtraction procedure. So for addition and subtraction, if you want to write down the correct significant figures, so you have to count put it in the correct way after the decimal point. So the least number, for example, 89.332 plus 1.1. So 89.332 after decimal point we have 3 significant figures. Meanwhile, for 1.1 we have only 1 significant figure after decimal point. So you have to write down your answer is 1 significant figure after decimal point, which is 90.434. 90.4. Okay. And then if you have multiplication and division, you have to remember that in multiplication and division, so you have 4.51 times 3.6666. We have 5 significant figures and also 3 significant figures. Only the least significant figures will be counted. So you round to 3 significant figures. So all of these we have covered last week. And then we also discuss about determinate errors and also indeterminate errors. So to be sum up, determinate errors and an errors that it is arise from known source, and also we can avoid it. Okay. And for the source of errors that come from determinate error, we have 3. The first is instrument error. The second is operative error or personal error. And lastly is method error. So for instrument error, it is come from faulty equipment, uncalibrated glassware not at calibration temperature, but it can also be avoided by proper calibration and maintaining the equipment. So for personal error, it is usually happen in the lab. So poor sample preparation, incorrect reading of meniscus, color of solution and endpoint titration is bias, mathematical errors, prejudice in estimating the measurement. So how are we going to overcome this? Yes, by proper training, experience and also discipline. And lastly, the serious error is method error. So it comes from incomplete reaction, impurities of reagent not soluble, and it's not stable, and have a side reaction. So how are we going to overcome this? It can be overcome by proper method selection and development. Alright, let's move to types and source of error. Random error. So random error is normally it cannot be totally eliminated and they originate from unknown sources. It means that the sources we cannot identify. So the deviation are very, very, very small. So if you can see in the graph here, the difference between determinate errors and intermediate errors, we can clearly see that the graph for determinate error does affect the average, alright, but for indeterminate errors, that random error doesn't affect the average, only the variability around the average are affected. So to sum up, that determinate errors is a very small errors which actually can be identified using an instrument. Alright.